My name is Kenny Daniel. I'm the founder and CEO of Hyperparam, and I take my coffee in Frappuccino milkshake form.
What is up, MLOps community? We are back for another episode of the podcast that you know and love. I'm your host, Demetrios. Today we're talking with Kenny about data, all about the value that the data can create, which is no novel idea. We've been hearing Andrew Yang say this since 2020, since probably before 2020. But I think Kenny brought a few new takes on it that we've lost our way when it comes to high quality data and how important it is. Let's get into this conversation with him. So back in my day, they used to call it ML. What what did your girlfriend tell you?
Yeah, well, in sort of all my talking and writing, I just write machine learning instead of AI. And she's like, "No, you got to put AI. Like, it's 2025." And yeah, she called me a boomer because I still call it ML.
She was like, "Okay, boomer, get out of here."
Exactly.
Yeah, man. I was mentioning to you that the favorite way that I've heard it phrased is, yeah, machine learning as it was called back in those days. And we just have shifted to AI. That's cool with me, I guess. We'll go with AI.
Yeah. No, exactly.
Yeah. Dude, well, let's talk data and and then let's talk UIs and interfaces because I know those are two things that you're quite passionate about these days. But data, you were mentioning you were just at NeurIPS. You couldn't find any talks that were data related.
Yeah. So I don't think it's a controversial statement to say that data quality is super important when it comes to LLMs and models and all that. Models in general are very sensitive to bad data. Everybody agrees on this. This is not a controversial thing. But people don't actually talk that much about data quality from what I see. I went to NeurIPS in Vancouver just a few months ago. I went looking for papers about data quality and I could not find them. I mean, I'll caveat that with say I found 3 papers and they were all in the vision space, which is cool. I'm glad that's happening. But like who's talking about text data set, for LLM quality? And
Yeah.
the fact of the matter is you can kind of understand why the Googles, the OpenAIs, the Anthropics of the world don't talk about it. They very much consider that their secret sauce because
Oh,
really the only thing that distinguishes, Anthropic from OpenAI's models and things like that is the data that they're training on, right? Everybody's using NVIDIA hardware. There's no hardware, arbitrage there. Everybody's using transformers, the same sort of gradient descent training methods. There's obviously optimizations and tricks and things that are used, but ultimately, the data is what defines the model. And so they don't want to talk about that. But why isn't academia? Why aren't researchers? Why aren't, hackers in their garage talking about this? This isn't something that needs, multi-million dollar budgets to make progress on. So that's kind of what I'm interested in right now.
yeah, it's funny how you say that nobody's talking about it. Even the llama papers, it's not like they do a full shout out on what exactly they did with the data and how they cleaned it. I mean, you'll get some stuff. And then I haven't gone through the DeepSeek paper that just went out, but I feel like they're a bit more transparent. I wonder if the reason they don't even want to touch that in these papers is because of the potential lawsuits that can come with it when they're like, yeah, we use this data set and we also use this one. If they start saying which data sets they used and how they cleaned them and whatnot, somebody from the New York Times is going to be like, you did what with my data? I think you're going to owe us for that one.
Yeah. Well, no, I mean, and that's fair. And like, look, I don't even necessarily expect them to talk about the sources of their data, right? Things to never ask a CTO, or their age or, where they get their data. Um, but, so, but that's not even what I'm talking about, right? I don't care if you're scraping it from YouTube or Reddit or whatever, right? They don't even talk about their pipelines. How are they cleaning and filtering the data? But you're exactly right about the Llama paper, the DeepSeek papers. These are some of the only glimpses that we get into, what people are doing. And it's still like less than a page of the total paper is actually talking about their data. But you do get these glimpses. And like the DeepSeek paper is great. They talk a lot about, the proportions of data that they selected, right? So it's not just about taking the entire data from the internet and just throwing it in an LLM. You also want to, choose, DeepSeek in particular did, I forget the numbers, but 60% code, 20% math, 20% English, 10% Chinese, whatever it is, right? Whereas Llama, they also talk about kind of their data distributions of, they went heavier on English. They still had a whole bunch of code. But, these are some of the decisions on the data that you're making to go into these models. And I do wish that it was talked about more.
Yeah, what are some other vectors that you wanna see data being talked about? Because, there's so much stuff that we could talk about. It does kinda baffle me that we're not talking about it as much, and maybe that was the 2020 to 2022 era where Andrew Yang was talking about that and it blew up, and so now people are like, "Yeah, we know, data's important, so let's just move past that." But it does feel like we haven't even though we know, we haven't operationalized it like you said, and we haven't figured out all the knowledge sharing and the learnings as we're continuing to advance.
Yeah, I mean, people might say they understand it, and yeah, I mean, I appreciated the era of sort of data-driven AI and all that. People say that, but then they don't follow through on it. Who's talking about that? I mean, there's obviously people out there making great data sets. There's obviously people working on this, but like, I think that this is underappreciated still, even though it's widely accepted. And I do think that there's a couple reasons. Well, so for one thing, these data sets are massive, right? You go to Hugging Face, like there's terabyte sized data sets that are, web dumps and GitHub and all these things, right? And so if you're a data scientist or a ML engineer and or AI engineer, how do you even approach that, right? Like, how are you going to get familiar with that data that's in these, multi-gigabyte data sets? I mean, it just seems like completely like a non-starter. So I think a lot of people don't. They just throw it at the models and hope that it's going to work. I do think though that there's some new techniques and some new things that could be changing this. And Llama is actually a really good example of this because they talked about in the Llama 3 paper. They used model-based filtering on their data sets. So this is cool. So what they did was, I was talking with one of the folks on the Llama team. They had this whole pile of data. I don't know how big exactly. They didn't train on that whole pile that they theoretically had available to train on. They actually trained on less than 10% of that total pile. So they had to take this huge pile and whittle
Okay.
it down to just the 10% that they want, which is a huge amount of data to cut out.
Yeah.
And so there's a question of how you do that. And they used Llama 2 to basically do a forward pass across their data set to label it, classify it, quality filter it, and use the models to reflect back on their own training set essentially in order to produce the next generation model.
Wow, so it was almost like Llama 2 knew, in a way, what it had seen before, and so if there was novel stuff, it would say, "Hey, this is good for the next iteration."
Yeah, I mean, there's a bunch of different approaches you can take of that. Looking at using the model to just classify things, so you can choose proportions, using it to like rate quality and things like that. You can also use the model itself to say, what can it predict, what can it model correctly, and what can't it, and that might also give you insight into the data.
Yeah.
Um, and this idea of sort of data set scale inference, I think, is really interesting because for the first time, we're kind of entering an era where it's feasible. Even just a year ago, if you looked at, what would it take to run a, state of the art sort of model against a trillion tokens of an input data set. And if I'm remembering correctly, it would have been, GPT for over a trillion input tokens would cost about $5 million.
Yeah.
It's pretty expensive. But then you fast forward a year.
You gotta be pretty confident in that investment.
Yeah, yeah, no, exactly. No, well, you got prompt wrong. You got to do it again. Yes. But now, if you look at 4.0 mini, it's much cheaper. You can do batch mode. So you can process a trillion input tokens for $50,000, which again is maybe not like, pocket change, but it's actually
No.
accessible to like the scale of the projects that many like enterprises or even, small scale projects could afford. And that trend is only continuing.
Yeah. One thing that I remember when we had the Databricks team on who trained DBRX, they were talking about how hard it was to know if the data was clean and proper. And especially one of the hard problems that still sticks with me to this day is in PDFs, you'll like ingest PDFs and then it will reference in the text a table. It will say see table 1 or see table 3.2. And then you don't know how to attribute table 3.2 because sometimes it would just get cut off and you wouldn't have this table is actually table 3.2 and it deals with this reference. And so that was a really challenging problem that they faced continuously, like being able to grab the tables, put them in a clean format, and then also have the text and that unstructured data around it that was referencing and gathering those insights from that table.
Yeah. Yeah, totally. So I think you're making a point, which something I like to kind of harp on. It's a little aside, but this is the sort of insight that you only get from looking at your data and in the context of the model, because people take web data, people take whatever data or take PDFs, and they use some package to convert those into just basic text so they can be turned into tokens. But
Yeah.
sometimes that very much messes up the data, or it misses like entire key sections of it, or it's out of order or things like that. And so I do think it's really critical to, and this is something I also harp on, is looking at your data and getting familiar with it. This is a thing that used to be table stakes in data science is,
Data science. Yeah.
yeah, just like look at your data.
Yeah, and the best data scientists were very familiar with the data because they were creating features that would mean the difference between a high performing model and a low performing model.
Yeah, totally. And so, like, I assert a little bit that this is kind of gone by the wayside, and I think it's partly because the data sets have gotten so huge. The models have gotten amazing at even dealing with just throwing a bunch of data at them, but it can be so much better if you pay attention to these things. Looking at how is it serializing tables out of the papers that it's doing. Is it parsing HTML correctly or in a way that makes sense? These are very very common issues. And from my time as a data scientist, as a boomer, um, that was a loop that I would
Back in the
do
day.
constantly, right? Yeah, I would like take a pile of data, I would build a model, and I would, look at, okay, great. Like, what of this data, whether it's in my test or training or whatever set, which of this data is classifying correctly and which of it's classifying wrong? If it's classifying wrong, look at it. Look at the examples, start bucketing those into error classes and starting to understand. Like, I don't think I've ever looked at my data and in the context of the loss or the sort of the classifications, I don't think I've ever looked at my data and not gotten some insight that ultimately led me to making a better model. So there's a tweet by Andre Karpathy which I really like, and in a certain sense, my new company that I'm starting, Hyperparam, is kind of entirely based off of this one sentence Andre Karpathy tweet from. And
Inspiration and everything, or you were already doing it and then he just rode your wave?
No, I mean, it was the inspiration. I mean, it's what I said, though. It's kind of the same pattern. It just kind of highlighted something that I've kind of done intuitively for years.
Uh-huh.
And so I'll try not to butcher the quote, but it basically goes, if you take a data set and you sort it by loss and you look at the extreme values, you're guaranteed to find something interesting and useful, which is basically the same thing. And there was actually a reply to that tweet, which I liked, which was, fun fact, if you take your data set and you sort it by almost any metric and look at the extreme values, you're guaranteed to find something interesting and useful. And
Fun
like,
fact, if you take your data set and you look at it, you're almost guaranteed to you spend enough time just toying around with it, that is so true.
yeah. And so, kind of started asking the question of, how can we do this at a larger scale? How can we make this, best practice apply to the world of sort of large data sets and modern LLMs? And like, I think that that's a really good way to, make progress on these and make better data sets in order to make better models.
I've been talking to a lot of people, and it feels like fine tuning is something that is not as in vogue these days as it was because of the risk reward or the effort to pay off type of scenario that you get yourself into. And you can get a lot of lift just with one shot or zero shot prompting, right? And just prompt tuning. that's just for fine tuning, which is a very low bar compared to if I want to go and train a foundational model. So, how do you look at like you're creating something that is for the cream of the crop type of person, or I, I can count the number of companies that want to train a foundational model almost like on my two hands?
Yeah, so I think that you're getting at a couple things there, and I have thoughts on many of them. The first thing I would
Yes.
say though is data is going to be important at every level of sort of the ML pipeline, right? Whether you're doing pre-training, it's still important. You can look at the DeepSeek Llama papers. If you're doing fine tuning, it's clearly very important. And over time, you just need fewer and fewer examples as we get better at this. But I will argue that fine tuning is still important. Although I will say if you can get away with not fine tuning, you probably should, right? If you can prompt your way or rag your way into a solution and not have to fine tune, like I agree. Like that, if I went into a company, like I would not recommend starting with fine tuning. But there are situations where there's just no better alternative today. And there's a couple of things I would say on that. I mean, there's certainly the instruction tuning and the supervised fine tuning and all the post training stuff. The R1 paper that came out yesterday talks a lot about really interesting methods. And what I think that partly shows is that the knowledge and even the reasoning and the connections and all that are already in the base weights after pre-training. We just need to figure out how to get them out in the most effective way. And
Oh,
fine
cool.
tuning can help with that for sure.
Huh. Oh, that's very cool to look at. It's just it's that latent. It's in latent space. We just have to get the right combination to the lock.
Yeah. Yeah, exactly. I mean, yeah, going from, the first person who told the model, think step by step, to now we're, training that in, baking it in, that it just does that on its own. So there's things like that if you're one of the, the bigger labs or doing fundamental research on this. But then there's other classes where I think fine tuning is still useful and probably will be for a while. And you could loosely or broadly call this style control. You certainly see this with the image gen models. Like frequently, if you want to, generate a certain style of cartoon or whatever, you fine tune it on examples, and now you can just do inference to generate things of that style. But this applies to text too. And so if you're building a chatbot, for your company and you want it to have a particular tone, a particular style of response, you want it to handle different situations in certain ways. Some of that you can put in the prompt, but honestly, some things like style especially are really hard to express with prompting, but they are easier to express with data. So you can use
Yeah.
data to express the will of the user.
Ooh, interesting to think about that. That it's easier to get to that end goal through expressing it in data and a highly curated data set that you're trying to go for as opposed to trying to prompt your way into the solution. Okay. All right. So that's a novel idea. I haven't heard that much. So I know that you had mentioned, I think we used the example of a radiologist. And if you're able to have a radiologist label a lot of image data and high quality image data faster, then you're going to be able to do more and create better models with that data. And it doesn't necessarily need to be a foundational model, and it can be that fine-tuned scenario, like you were saying.
So there's the question of, expertise and sort of pulling that out of the user and the model builder in a certain sense. And historically, there's various services that you could use. There's things like the Scale AIs of the world, a million other labeling companies that are out there, which was incredibly valuable, especially in the early days of, doing these models, right? Because they would go, label self-driving data, label text content for harmful content, things like that, annotating data in general. But it's one thing if these are tasks that, kind of any human could do, right?
Um,
Identifying a stop sign, great. But yeah, to your point, what if this is specialized? What if this is medical data? What if it's finance? What if it's legal? What if it's sales in some particular domain? And then there's the question of you probably can't outsource that. And I know that there's companies that are definitely trying to hire more experts in-house or become experts at, connecting companies that need data with the relevant experts. But I think personally that's probably the wrong way to go about it. The benefits that you get from something like Scale AI is you get the scale, right, of having all these humans. You can bring them in and swap them out as needed. But if you need a team of expert radiologists, I don't see how Scale AI can do that and then keep them on staff unless it's just, on demand and then get rid of them. At which point, why not do it in-house? And then also, more and more, the chatbot is becoming the user interface to a lot of products, right? I mean, that's certainly true with ChatGPT, but there's a million
Like it or not.
enterprises.
Yes, that is very true. Yes.
Yeah. And so how do you control the interface of a chatbot? And it's kind of through this data. It's through fine tuning, it's through style control, it's to some extent through prompting and RAG and the data that you make available to it. But generally speaking, at a company, it would be kind of crazy to outsource your core user interface to, unskilled labor, right? That's something you want to own as a company is the interface that your users are experiencing and how they do that. And in the world of machine learning and AI, you do that through controlling the data, which controls, how the model behaves. So I'm a big advocate for trying to move that in-house as much as possible. Uh, just as a concrete example, even before I started my current company, I really like JavaScript. I'm sure we'll come back to this, revisit this in the talk, guys. I really like JavaScript because I believe deeply in the importance of user interfaces and good user interfaces. And if you want to build good user interfaces, it kind of has to be in the browser. And so it kind of has to be written in JavaScript. Okay. We'll come back to that. So I wanted to build the world's best JavaScript generating code model. This is still kind of an
Nice.
ongoing project of mine just for fun. I went and I, looked at Hugging Face. I looked for data sets. There's Star Coder data was a good one that I found, which is basically just a dump of GitHub from some point, and started, filtering it down to sort of, the JavaScript code. And I wanted to start fine tuning. At the time, it would have been Llama 2. Now I'd probably be going Llama 3. I wanted to start, fine tuning on this, but I wanted to first look at the data and get a sense of what was in the data because, you know, I am, JavaScript expert, right? And so like I should be the one sitting there and determining like, is this code too short? Is this junk? Is this just comments? Is this just, something that shouldn't even be there? And I actually found it surprisingly hard to even look at the data using sort of common contemporary data science tools.
Oh, wow. Because it was too much data.
Yeah, I mean, there's a huge amount of it, and, I'll go on a little bit of a rant here. I
Yeah.
would actually argue that Python is part of the problem.
Oh.
No,
What?
shots fired. So, machine learning and AI, like, lives in this Python world, and Python is great. I mean, there's many reasons why that's the case, right? I've written unimaginable amounts of Python code in my life. But Python is also arguably the worst language you could choose when it comes to building a good user interface. So
Yeah.
I actually think that like people in the world of machine learning and AI don't even appreciate how bad they've had it when it comes to user interfaces.
I mean, we got Streamlit, right?
You're making my point for me.
Exactly.
Yeah, well, so no, you're exactly right though. So the two probably most popular ways to build a UI or interface with Python is Streamlit for one, which again is great for building demos and just mapping directly from those sort of Python native objects to something you can display on a screen. But it's so painful when you start try to create like interactive websites. If the state is updating a lot, things jump around. If you try to make like a chat interface with Streamlit, it's a nightmare, like, trying to get it to actually just jump down to sort of the last message and not, blink the screen every time the state changes. I could go off on this for a while. But okay, so there's Streamlit on one side, at least it's customizable, though, and then you've got notebooks, which,
Mhm.
also, Jupyter notebooks are great. I'm not hating on Jupyter notebooks at all, but they serve a particular purpose, and they're not as general as you might want.
Yeah. And it's not for user interfaces.
Yeah, fundamentally not. But it does bring Python stuff into the browser, so that's good. So that's where everybody lives, right? As a, data engineer. So I downloaded, a Parquet file from Hugging Face. Two-thirds, just aside, but two-thirds of all the popular big models on Hugging Face or data sets on Hugging Face are natively in Parquet format. Uh, and the remaining one third get automatically converted to Parquet by Hugging Face, right? Like they automatically do this. And I had worked with Parquet before, but Parquet is a very cool format. I think we'll revisit that a bit. But this was kind of some of my first real experience with Parquet was downloading the star coder data and just trying to look at it. And you pull it into a notebook. You do import pandas, pandas dot read Parquet, and you give it the file, and it prints out this table. And the table is not interactive. You can't even paginate through it. You can't click like next rows. And in the case of the data set that I was working with, each cell is an entire source file, but it doesn't display it as a whole source file. It just displays it as a tiny little box that you can't actually see. So
What a
I was
headache.
very quickly frustrated that like I can't even see my data, the most basic, first step of good data science. And so that kind of is what started me down the road that I'm on of trying to figure out, how can we build better interfaces to benefit AI and machine learning people?
Yeah, and I think the key takeaway that I'm hearing is there's a lot of Python that's out there. When you wanted to create your JavaScript model, you had a hard time just weeding out the Python and making it a JavaScript native type thing. Is that also another piece?
Yeah. Yeah, absolutely.
Let's also talk about, because we are on the topic of UIs, the way that you envision getting more out of your data from experts, but also from folks that are going to be dealing with these large data sets, because it's almost like you have two users of a platform. Maybe it's two separate platforms. I don't know how you envision it. And one is there's the labeling, the expert labeling platform, so that if I'm a radiologist or a lawyer, I can label quickly and faster and use LLMs to help me have that workflow be supercharged. And then on the other side, it is someone that's in your position that is looking at this gigantic data set, and you want to know, where are there holes in the data set? Where can I make this data set more robust, or whatever it may be, to figure out the best way to get the highest quality from that data?
Yeah. So I think that the persona sort of question is an interesting one. Ultimately, I do think there will always be some specialization of, the people focused on the model building and then the people with the expertise. But I think that's a little bit also of a false dichotomy, and that the more you can get the real expert sort of doing the work and not just throwing it over the wall, the better. Um,
Oh, yeah.
and I think this is what a good user interface can actually enable. So one example I might go to is Tableau, right? Before Tableau came, like when Tableau came along, it didn't really enable people to do anything that couldn't theoretically have been done before, right? A good data scientist could look at the data, they could come up with queries, they could build a dashboard.
Huh.
In a certain sense, what Tableau changed is that, a manager or, like an executive could query, do it themselves. They could play with it and they could build, explore the data, get insights, using things that's only kind of in their head, and do it themselves. And this enabled entirely new use cases. Not that they couldn't necessarily have delegated that to somebody, but just for like little explorations or just curiosities, you're probably not going to, delegate someone to go do that.
Yeah.
And so that's kind of what I would love to do here is that if you make the interface really easy and you make it so that, one person doesn't feel so daunted by, the massive scale of this data, but they can actually start looking at the data, getting insights, whether you're the radiologist who maybe doesn't understand the first thing about linear algebra, but you do understand if an X-ray is misclassified, or
Yeah.
maybe if you see that it misclassified, why. Maybe you can look at the image and kind of understand like, oh, it's picking up this, or it's picking up this, or it's picking up the text from the edge of it, and then you can actually start to make data fixes against that.
Yeah, and recognize, I think I've seen a few companies generate almost like 3D maps of the data, like you see sometimes with embeddings,
Mhm.
and it will show you like where you have a lot of data points or a strong set of data, and then where you have the outliers and you have a bit of edge cases, or you just don't have as many examples there for that. And if we're talking about the radiology example, it might be that there's a certain kind of cancer that you have very well documented, but then other types of illnesses you don't have as well documented. I do also like the idea of bridging the gap between the modeler and the expert and allowing the expert to come in and look at what is going on with the data set and say, do we have any examples of XYZ? Or what's going on over here? Oh, I can see that we're misclassifying a certain topic or disease or whatever.
I think what you're also getting at is sort of another interesting direction that I think that things are going to go, which is using the models to assist the user, but not necessarily even just as a classify this row as X, but in many ways actually acting as the user. You can think of this with like agent kind of style approach to things, where if a human, data scientist can do this, right? I learned this in school. Like I've taught data scientists on my teams, sort of this kind of repeatable process of, get the data, build the model, look at where it's doing well and iterate to get to the best models. This is, in a certain sense, this is science, not art, or at least it's at least a teachable, repeatable process. And so if you can teach this to a person, why couldn't you teach this to a model? And so I'm really interested in that question of, yeah, how can you automate more of the work of an ML engineer? Can you have the models look at the data, much like a person might, and try to form hypotheses about, where is it misclassified? What are the buckets of errors that are happening? And, which data is relevant to those so that we can actually start to try to fix those.
Yeah, so it's not only having the model look at each individual data point, but looking at the data as a whole data set and saying, oh, we might want to figure out what's going on over here.
Yeah. Yeah, exactly. I definitely think we're gonna see tools like that coming out and being used more and more, and ultimately leading to creating sort of, the next great data sets that are out there.
Wow. Yeah. And so then how does the work with creating a brilliant interface intertwine with this? I guess in this case, if it's a model, you don't necessarily need data visualization, or maybe you do. Maybe there's different modalities that you're giving to the model so that it can look at these data sets differently and get different insights on it. I don't know. Like I want to know what's your vision on the actual interface and then how you can have a model sync up with that interface.
Yeah, so in a certain sense, you could imagine these being sort of two unrelated things. Like one is the UI rant, and then one is the use models to assist with the data curation. I think that they work together though really well. And I think that if you take just one approach or the other, it's going to fail. And there are companies out there trying to do things like purely model driven data set improvement, where, literally, you send them a data set in whatever CSV or Parquet format, they do some magic and they send you back an improved data set. But what that's missing is having, the expert in the loop, having the human in the loop who actually understands what they want out of this model. And the only way you can bring them in the loop, a user interface is for people. It's for humans, right? It doesn't really help the models. It is the way to keep the human in the loop guiding this model building process. And that's key because we've gotten very good at training models. They can learn almost anything that we can define an eval for, right? And so I really like this question of evals, but like in a certain sense, what is an eval? But it's trying to pull out of people what, the description of what they want the model to do.
Yeah.
And so that's what whether it's creating evals or data sets, like I think these are sort of opposite sides of the same coin, where it's expressing the user's intent via data.
And then just iterating over the outcomes until you're getting closer and closer and passing these evals.
Yeah.
Okay.
And so that's why you need the interface. But then on the flip side, why do you still need the model driven approach? Well, that goes back to just the scale of the data, right? A person doesn't have enough time in their lifetime to look at a whole data set,
A billion. Yeah.
right? And so that's where you need the models to act as a lever and you need the UI so that the user can express their intent.
Fascinating to think about. Yeah. Okay. I can see this. All right. Well, what else? What else you got in there? Because this is blowing my mind. I think the key question that I have is what unlocks do you see if we can get better data sets faster, bigger, better data sets faster, and that becomes a much more seamless process. Like, what does that enable us to do?
I mean, I think that that is really like the key for all the progress that we're seeing in models just in general. And I think it's the biggest bottleneck in a lot of ways, right? Is that data. And, from an engineering point of view, if you've got a pipeline of things, right? And there's a constriction, there's a bottleneck, right? Like applying engineering effort to like any other parts of the pipe is not going to help. Like the only thing that's going to help is, like widening the pipe where, the bottleneck is. And I would argue that's the data, and I would argue that's the evals, especially. Because again, an eval, I'm going to oversimplify a little here, but in many ways, an eval is just a very clean data set.
Huh.
There's some nuance there, right? But in a lot of ways, that's true. And like the models have gotten, and we've gotten extremely good at the models learning almost any function that we can define, which is why like we're in an era right now where even just defining a good eval can make you famous. Right. I mean, like ArcAGI as an example. I mean, Francois Chalet did plenty and all that. But like, why is it being talked about now? Because it was the hardest eval out there and it just fell.
Yeah. Yeah.
And so the question of, yeah, how do you make better evals? How do you express what you want these models to do? Every time I hear somebody say, "Oh, I tried, the new O1, I gave it a problem and it failed." Like that actually makes me excited. And the question that I go to in my head is, how would you build an eval for that? The failure. Because like if you can define an eval, like I would bet you anything that within 12 months, like that eval will fall.
That is really cool to think about is how when you know the problem, it is pretty inevitable that we can supersede the problem within a certain amount of time. You just have to know where it's failing. Okay, so going back to this bottleneck piece, which is another fun thing, and I can tell that you are and have been a founder because that's also like in organizations, right? You got to optimize and you have to focus on where there's the bottleneck because if you optimize any other piece, it just doesn't make sense
Yeah. It just backs
because
up more. Yeah,
yeah.
exactly.
So then looking at the data and looking at the evals, I mean, are you thinking about in this UI that you also are going to have ways to create evals? Because evals feel like the other side of the spectrum. Like it's after the model is trained and after the everything has happened, then you're doing evals, but the data sets are over here very upstream, right?
Yeah, and honestly, like it's a very early stage startup at this point. I'm a solo founder, so I don't necessarily know what direction it's going to go. I think evals are going to be a big part of the story. I also think training sets are going to be a big part of the story. I mean, one of the nice things about data is that it does apply kind of across the board, right? And if you make data improvements, it's also more robust to changes in the technology space, right? If I
Hmm.
spend effort and time improving my data set, that's gonna pay dividends for years to come, even when, we go from Llama 3 to Llama 4 to Llama 5 or whatever comes out, right? If you have better data, you can now go fine tune that on the latest and greatest model. If you're spending that time instead on, buying more NVIDIA GPUs or, hiring researchers to improve the architecture or manual feature sort of selection things, and then a new model comes out, all that other work gets thrown away, but the data persists.
Someone was telling me just yesterday that they spent so much time doing all this hacky stuff in the beginning when they were working with GPT 3.5 just because they were trying to get longer context windows, for example. And then new models came out and they had longer context windows built in. And it was like all that work that I did to get that longer context window and it all went out the window. And I've heard people talk about this as like, you want to be thinking a little bit like forward compatible. How can I do things that are going to continue to pay dividends, like you said? And I don't see a world where you making your data better in every way possible is ever going to be like, all right, well, the new model came out and now it doesn't matter. All this like high quality, unique, proprietary data that we have doesn't matter anymore because the model can do everything.
Exactly, yeah, no, but nobody's ever regretted that. And there's I think
Yeah.
there's a more general principle, which in a certain sense sounds really obvious, but don't build a company betting against the models getting better,
Mhm.
right? Which again sounds obvious, but like people do that. People are like, oh, well, sure, like maybe the models are going to solve whatever it is, SQL generation or whatever it is, but today they're not. So if we make just, a marginal improvement on the current state of the art on a narrow thing, like great. But like you have a very narrow time window where that's going to be true, would be my bet. But if you build things, if you build, scaffolding, I mean, in my case, like if you build a strong UI, I can swap out the model underneath it, in a moment, and the UI is still valuable. Like that's my personal, bias. But I think that there's a lot of examples out there of companies where you can build something that's still useful today, but only gets more useful as the models get better.
Mm. But wouldn't it be the the end state, me as a company that is using a model, is there a moment in time where the model's so good, like you said, don't bet against the models getting better. The model's so good that I don't need my data anymore. So that kind of assumption that we're saying right now, the investment in our data is always going to pay dividends, could be the wrong assumption.
Yeah, but it's still not gonna be an absolute everything model, right? Like, it may solve generic problems, but, like, is it gonna know about your business or your specific domain or things that just don't exist on the broader internet for it to train on? And I don't think that's gonna go away. And then I mean, you look at even particular enterprises, things like building, enterprise, like, BI tools or process automation tools or things like that. You're like, yeah, you could take the smartest person in the world, and, like, unless they have the context of
Yeah.
what does the business do? What do these tables mean? What does this data like mean? What is revenue? What is, like, what are these like, it's not about intelligence. Like you need access to this data. And like the
Yeah.
cleaner and like, better, formatted and structured and, junk removed it is, that's going to be better whether you're a person or a model looking at it, or it's the smartest model on earth, right? You still need that.
Yeah, that is a great point, and that is one of the reasons actually, when I was talking to a guy earlier this morning, and he was saying that he built this agent that was working really well on Jira. It was like a Jira agent that they built for the company, and when they built it in their hackathon, it was working brilliantly, and then they plugged it into their real Jira instance, and it was horrible, and the reason for that was because everybody on the Jira boards would do the least amount of context to get their ideas across to the other human, and the other human's working on the project. They've been steeped in the project for the last 2 weeks, so they don't need a lot of context. They get like, there's a lot, even the "looks good to me" is something that maybe it would make the agent be like, "What's going on?" It doesn't understand the acronyms, it doesn't understand any of this context, and so there's that piece. I don't know if it's a little bit of a getting sidetracked in the conversation on the high quality data, but I do think that the reason I brought this up was you want to tie back the context to, no matter how smart you are, if you're not able to understand the context and be brought up to speed on different projects, then doesn't matter.
Yeah. Yeah, exactly. And then like, the entire field of computer human interaction, right, is not going away, right? Even if we had, the God model that is like all intelligent, right? You still need to figure out how it interfaces with the human systems that still exist and will exist.
Yeah. Huh. Yeah. Oh man. So what else you got before we get out of here?
Yeah, I mean, I think we hit on a lot of the core points. One thing I will just say is that, I'm building a lot of this user interface stuff as open source. So this isn't, shilling anything, right? As one example, we were talking about Parquet stuff earlier. So Parquet is a really interesting format. It's a column-oriented data format that has its own index in the footer. And if your listeners ever use something like DuckDB to query, you can query against Parquet files even up in, say, S3 or in the cloud without having to pull the entire file down. And it's the index that enables you to do that. And so this is really cool. Like, DuckDB, I love DuckDB. It's awesome, right? It's changing how people also do some of this data set exploration things, right? I love, like, they have a sticker that I got at their offices the other day. It's like, my laptop is faster than your data center, right? But anyway, so they do these cool tricks with Parquet where you don't even need to download these gigabyte sized, Hugging Face things. You can just point it straight at Hugging Face. And so I started thinking about this, like, could you do that in the browser? And I went looking for a JavaScript Parquet library, and there were some out there, but they had all gone abandoned. Like, you go to, like, the one that had the most stars when I started the project was Parquet.js on GitHub, and, like, at the top of the repo, it had in big letters, like, "This project is abandoned, like, let me know if you wanna take it over." But, being a good engineer, rather than, like, taking the reins of, like, an existing project,
No,
I started from scratch writing a new one.
of course.
Yeah.
Yeah,
No
because there's too many
dependencies.
opinions that they had. Yeah. No
Yeah, right.
dependencies, exactly.
Yeah, 0 dependencies, just from scratch, pure JavaScript, Parquet parser. And opening the first one, opening up the star coder data actually only took me a couple weeks. What I didn't fully appreciate going into this project was sort of how sprawling of a format Parquet is. In order to be as efficient as it is, it has like 7 different compression formats supported. It's got like 8 different encodings of delta encodings and all this various stuff, which makes it efficient, but is really annoying if you want to support all the Parquet files. So what started as a couple week project quickly turned into a 6 months to release the library High Parquet, which I am proud to say is the most compliant Parquet parser in existence. Which is, I know, a strong statement, but there's a Parquet testing repo on GitHub by the official Parquet project, and I can open more files from there than the official Arrow implementation, than the Rust
Wow.
implementation, than all of these, and it took a lot of work. But what this enables me to do is really cool tricks, like, you can have a Parquet file up in Hugging Face, and you can pull it into the browser, just the parts that you need using HTTP ranged GET requests. So you can browse the table and you just fetch rows, 100 through 200 on demand without having to pull in a gigabyte of data. And so I'm using this to kind of build these
Wow.
UIs, but it's open source and it's out there. There's a Hugging Face space where you can use this actually to browse the Hugging Face datasets faster and more efficiently than you could even on like their own built-in viewer. I will give a shout out though. Hugging Face noticed this work and they gave me an open source grant to continue developing this. So shout out to Hugging Face.
Oh, no, to them. Yeah, that's very cool. But it's not doing anything specific with DuckDB. It's just that, like, that was the inspiration behind it,
Yes,
right?
that was just the inspiration, right? Because so people have done this kind of trick where they will literally compile DuckDB to WASM and embed DuckDB in the browser to do these kind of tricks, which is cool, but it's like 40 megabytes of like compiled like stuff to pull into the browser, which is not like a great experience if you're trying to have a fast loading website.
Or if you're trying to do anything that day.
Yeah, yeah, no, exactly. And so, like, that was where, I built this library, minified and compressed. It's under 10 kilobytes in order to implement the full Parquet spec, and you can pull in just the data you need. And so, like, I would love to see people using this to like build, compelling user interfaces for AI data.
Yeah. Oh, that is very cool because basically you're giving yeah, you're giving the reins to someone to be able to just explore all of Hugging Face datasets within the browser. No need to spend the time downloading, then loading it up, exploring there, and then finding out that actually this dataset kind of sucks. I was going to mention on the topic of Parquet, there is a really good Substack that I saw probably a year ago from Jay Chia, I think, who is at Eventual Computing. They have like Parquet Part 1 and Part 2, and they go into so much detail on everything about Parquet. Like, it is the most in-depth post I've ever seen on it, and then I talked to Jay about it, and he said, "Yeah, that took us 5 weeks to write." So, and it was like they know all this stuff because they've been dealing with it. They're very intimate with Parquet, and they had to go and they were going back and forth with the what is it? The Parquet Foundation, or what did you say? There's
There is, I think, a foundation. I mean, it's under the Apache, like, software
yeah.
foundation, but I think that there's, I go to their meetings, I forget what they call the group.
Yeah, I can't imagine the difficulty in that. I'm trying to find the actual trying to find the Substack. Oh, here it is. Working with the Apache Parquet file format from July 12th, 2023 in the Daft Engineering blog. I'll throw the link in the show notes too, so anybody who wants to check it out. And I think you will like this if you haven't seen it before. You may have gone over it when you were doing your research.
It's entirely possible because I've read, like, a lot of stuff that's out there, and ultimately, though, I read the source. Like, you go to the source of truth ultimately, right? The implementations. Like, I
Yeah.
read the Apache Arrow source code for Parquet, I read the Rust client for Parquet, I read the DuckDB source code for Parquet, and I will say this, just shout out to DuckDB. It is the most beautifully architected, engineered code base that I have ever worked with. Like,
Wow.
Arrow was like everything is split up everywhere. I don't even think I figured out how to compile it. DuckDB has like no dependencies. You just run make. You can make
Yeah.
changes in the source. You run make. I mean, it takes a few minutes, but like it's so clean and elegant. Like that was like my primary reference for sure.
And you were mainly working with DuckDB, right? You didn't do anything with, like, Mother Duck on top of it.
No, I mean, no, like the Mother Duck people are great and like they're here in Seattle local, but no, I mean, I was mostly just looking at the source code of DuckDB, but
Yeah, it is amazing how much traction and how much love they get, and I think much like you, many developers have gone through that same experience and been like, "I wanna use DuckDB for everything now. Can we just make DuckDB that does it all?" So, it's cool to see that.
yeah.
But dude, let's talk about Algorithmia because there is a really cool thread to pull on, which is like you were so ahead of the curve. And for those who don't know what Algorithmia is, like break it down for us. What was it? It was sold in what, 2022?
I
Fairly
think it was
early?
2021 that was sold to DataRobot. Yeah.
2021. There you go.
I
Like
know, it was early.
very
Um,
early.
yeah, no, I mean, yeah, so just to give a little bit of the background and the story there. So I was doing my PhD in artificial intelligence at USC, and I like to joke that, I was studying AI before it was cool.
Yep.
And it was during my time at my PhD that, sort of similar to what we were talking about the bottleneck thing, right? Like right now, I see the biggest bottleneck as the data to building the best models. But back then, when we founded Algorithmia in like 2014, 2015, the biggest problem was often the hosting and the serving of these models. And like the models, I mean, this was pre-BERT, this was pre, kind of everything. Uh,
Free
but it
anything. Yeah.
but it was still the early days of deep learning. Like we were starting to see the promise of it and some of the early results. And so in the very early day, like within the first year of Algorithmia's existence, we had serverless hosting of ML models over GPUs.
That sounds very familiar. I don't know why, but I feel like I know a few companies doing that these days, and they're just cleaning up.
Yeah, yeah. No, I mean, and I mean, it makes sense, right? Like, it's a hard problem. It's a hard engineering problem to make this work. And we were doing this, just to our horn a little bit. Like, we were doing this before even AWS Lambda came out. So we were doing
Yeah.
serverless hosting of these things kind of before the concept of serverless was even really like a thing. And still to this day, you can't run lambdas over GPUs.
Yeah.
But yeah, but so the reason why we started down that path was we wanted to build this marketplace where developers could come or scientists or ML engineers could come. They could take their trained models, they could put them up as an endpoint, as an API endpoint, set a price for that API endpoint, and then people could come and like call those models. And our idea was is that, you put up these models, people would sort of the free market would create this competition for people to create more, smarter, faster AI.
Yeah.
And it was cool. I was really excited about it. In many ways, it looks kind of like what the Hugging Face Hub looks like now.
Yeah.
And what I will say is I think we were too early. I mean, timing's kind of
I was
everything,
gonna
but
say that 100%. Like 2015 trying to do serverless GPUs when the demand for serverless GPUs is happening now in 2024. It's like you were a decade too early.
yeah, arguably. And but like even ignoring kind of, the practicality of it and the demand for it, like the models weren't ready yet either, right? So we had people putting up models and they'd be, text to speech or OCR or things like this. And like, sure, it would, or like even more narrow things, right? And it would solve one problem and it would solve it okay, but it wasn't generic. So how
Yeah.
do you have a free market or when there's no, substitutable goods, right? Like,
Yeah,
and
nobody's
so
gonna pay for a model that just does one thing in one company on their data, that type of stuff, yeah.
exactly. Everything was too narrow. Everything was too vertical specific. And so what happened over time was that rather than being a marketplace, we saw people uploading their model, keeping it private, and then calling it themselves.
Oh, then you're like, "Pivot."
Pivot literally though, right? Yeah, and like so it's because that's not a marketplace dynamic if there's not like a two-sided thing. That's much more of an MLOps kind of thing, right? It's how do you host these models? How do you manage these models when you and like look, like anybody could deploy model V1, right? Like it's not that hard to spin up EC2 and let's like throw it up there. But like what happens when you come out with model V2 and you want to, roll it out like and deprecate the old one? What happens when you have 100 or 1,000 of these models and 99 of them are never being called? Well, you want to like spin those down to cold storage, but be ready to spin them up if they do get called. But then as the models got more general, right? Probably starting with BERT, especially, but obviously, even more so in kind of the modern era, you actually do like every model can kind of solve every problem, like to varying
Yeah.
degrees, right? Some are going to be better than others, some are going to be faster than others, some are going to be cheaper than others. But broadly speaking, like, you can take any given problem and you can throw it at GPT 3.5, you could throw it at GPT 4, you could throw it at Llama, you could throw it at DeepSeek, and like one might be better than the other, but they all kind of work. And so I think that works a lot better for, say, the Hugging Face Hub than like what we were doing back then.
You see companies, and I kind of look at it as these companies today, like the Modals and the Base 10s and the Togethers even, it it was like that's what Algorithmia was doing back in the day, right? And there was this gap that happened where 2021 you sold, and then it was a year until ChatGPT came out, and then it was even longer. I can't even remember when the open source models were coming out that we would potentially it was Stability that came out with like or
I
sorry,
mean, Mistral was kind of the original like open
yeah, that
like
was
LLM, right?
earlier, but that wasn't even that early. I think that
No,
was
I mean, yeah,
still
there
pretty
was stuff
far on.
before that. That was the first compelling one to me, but like Mistral
Yeah.
7 billion, that was a great model.
Yeah, and that was in 2020, end of 2022, was it?
I
Or
don't know.
2023? No, it was end of 2023, so that's a 2-year gap that then all of a sudden folks were convinced that the thesis of, "Okay, open source is gonna be as good as what we have closed source, is just gonna take a little longer," and then there was the other piece on, "Oh, well, if I don't have to deal with all this headache of these large models and the inference around it and trying to, like, host them, why don't I just outsource that to somebody else? I don't need to spend that much engineering time on it because there's other companies that are doing this," and also it can be price
Yeah.
effective.
Well, just from a practical point of view, like hosting models is like the perfect example of like economies of scale, right? ML ops kind of things, right? If you're one company and I just want to host my models, like I have to now spin up infrastructure for that. If it's not being used, I'm just wasting idle resources. If I want it to be accessible fast across the globe, right? If I have users in Australia and I want, like 50 millisecond like time to first token, you physically cannot do that with the speed of light if you don't have servers in Australia,
Yeah,
right? You
yeah.
can't go to US East 1 and come back that fast. And so like now for one company to have to spin up a global CDN of hosting like models, it would be crazy, right? It's the perfect situation for there to be a central company, whether it's a startup or, like a big infra provider, but like it's not the sort of problem you should solve as a small player.
How were you guys doing it? Were you buying GPUs yourself, or were you renting them from the cloud companies and then
No,
just
we were
adding
renting them from the cloud companies, yeah, and we were fighting with shortages and all of that, but
before it was actually from real shortages, huh?
yeah, yeah,
With you were fighting with all the crypto miners.
probably, yeah. Yeah, and then there were well, and you're talking about that window of time, right, where before ChatGPT, there was a crypto crash, there was, like, that brief, beautiful moment when GPUs were abundant, uh,
Yeah.
But also, like, I mean, you made the point of, like, Algorithmia got acquired 2021, late 2022, ChatGPT came out, and, like, it's impossible to not think about that alternate history where, we had hung on for, like, 1 more year or something, and, like, ChatGPT comes out, and wow, we've been, in the ML, like, hosting over GPU space for almost a decade at that point, like, probably could at least raise.
Because the other funny piece on this is that there's another company that was in almost like your batch, we could say, that was doing similar things, and I would consider that like Octo ML, Octo AI,
Mhm.
and they also got bought though. And so they got bought much later, but still they got bought, and I think it's trying to it's like the new batch of folks that came out and solely focused on the LLMs or the AI narrative, they ran away with it in a way.
Yeah. I mean, and, like, look, especially after, going separate ways from, the acquisition and all that, and I was starting to think about my next company. I mean, my mindset went to, like, ML infrastructure, ML ops, hosting. I still have a lot of thoughts about that, right? I spent a lot of time thinking about, like, well, yeah, say we had hung on or had gotten funding, or maybe even not. Maybe if it wasn't Algorithmia, but if I just wanted to build from scratch a similar platform, but for LLMs, and there would have been differences, right? Like, we had some assumptions with Algorithmia that it was one model, one GPU, or we could host multiple models on one GPU, but we couldn't do multiple GPUs for one model
Oh,
because they weren't
not
that big
yet.
then. It wasn't big
Yeah, they
enough,
weren't that
right?
big.
And so, like, that's a bridge that you could cross, but, like, it might require some serious engineering. So I definitely spent a while thinking about, like, how would I have architected an hosting platform now for LLMs? But also, there's a lot of smart people and companies that are now in that space and thinking about it. I s Although I will say I don't know that any of them have really won yet. Like, there's not,
Mm,
like, a clear thing. I mean, I looked at
no,
this the other day of, like, I have these, serialized, like, GGUF or whatever model files, like, how do I host these in a serverless sort of way? And there's obviously solutions, like, I was kinda honing in on Replicate and some of those kinda ones, but, like, there's not a clear winner. And it's
no.
crazy to me also how bad AWS's approaches have been, but
They just don't care, man. Like, let's call it spade a spade. That is but one thing that is fascinating to me on this is we had Aditi on here from Kleiner Perkins probably a month ago or 2 months ago, and he was talking about how if you look at the AI space and the ML ops and the LLM ops and the agent ops, whatever ops you wanna call it, the ones who are actually making money are the GPU infrastructure folks because you can do AI with whatever orchestration tool you want or whatever data cleaning tool you want or whatever. All that is optional. What's not optional is GPUs. If you're doing AI, that is where the rubber hits the pavement.
yeah. Yeah, I mean, that's certainly true, that there's a lot of money to be made on GPU arbitrage at the moment, right? Yeah,
Even
I mean,
that,
there's absolutely, yeah, like the Togethers of the world and the things like that, raking it in because, like, anywhere you can get GPUs. I don't know how that's gonna play out. I mean, I don't think demand is going away for GPUs. They're obviously, like, cranking them out as fast as they can, but I don't know. It'll be interesting to see.
yeah, and like you said, there's no clear winner. It looks like there's a lot of success all around the board, and the GPUs, the real money that's being made in the GPUs is the inference side of things. And I'm sure you saw that too, like, you were just doing inference, right? You weren't
Yeah.
doing any training, you weren't doing any so
Oh,
yeah.
yeah, and that is something I was pretty proud about Algorithmia, just in the sense that, like, a lot of people either conflated the 2 and they just said, "Oh, well, a GPU is a GPU. If you wanna do training, if you wanna do inference, like, it's all the same." But, like, the workloads are so drastically different that, like, you really wouldn't actually build the same tools to do training versus inference.
Yeah.
And so the fact that we focused on inference was also, I think, something that was ahead of its time, because it is also, I mean, that's the sort of thing where you want, like I said, you get the benefits of scale. You can swip, you better utilize slack capacity when you have a wide range of demands. There's economies of scale if you want to go global and deploy to different data centers. Whereas for training, right, you want a big pile of GPUs in one room with very high interconnects for a short period of time, or maybe,
Yeah.
longer if you're doing big training runs. But like, and so it is very different. And then I think in the world now, we're actually seeing that a lot. Like, there's obviously money to be made in training, especially if you're NVIDIA, but inference demands are off the charts, right? Like, Claude or Anthropic can't keep up with demand because they don't have enough GPUs for inference. And with the O
No.
models, the O series of models, I mean, the speculation is that like that's what OpenAI is really like trying to build these data centers for, is not for more training, but they just see the demand for inference of test time compute and like chain of thought reasoning at test time just going crazy. And
Exploding.
so yeah, I mean, I anticipate inference to be increasingly large percentage of the total like GPU spend.
Awesome, dude.